Hello, my name is Bryce Turner, and I will be presenting on my final project for my deep learning class, CSCI-89 at the Harvard Extension School. My report is titled Deep Learning for PCAP. I train a CNN classifier on packet level data to distinguish between malicious DNS traffic from various botnets and normal DNS traffic from computers running standard software applications. I take advantage of an interesting data set where researchers at the University of Victoria constructed a virtual cloud and then deployed many botnets on these different VMs. The researchers then observed all traffic transmitted inside of their environment, including the packet level information. This interesting data set resolves two common problems in cybersecurity. We often do not have much labeled data, and we do not have normal baseline activity for a given system. I believe that if this data simulation could be expanded, the framework deployed here could be used to create a packet sniffing application that would detect botnets as soon as they begin executing on a system. All of the botnets here are essentially controlled. This report focuses only on the DNS traffic, because oftentimes botnets will use DNS traffic to transmit command and control communications with their central servers. I only knew the IP addresses of the central servers. The model I constructed is a one-dimensional convolutional neural net, where I tune the depth of the network and the kernel size. I use a CNN because the data was bytes in the packet, which is essentially unintelligible to human eyes. Therefore, I thought it would be better to let the CNN conduct the feature engineering. Given that the data is read as a single 1D stream, not 2D like an image would be, the CNNs further had to be one-dimensional. After each CNN layer, I included a max pooling layer. In future work, I could change this max pooling to include a dropout layer as well. These results are very, very good with very high accuracy on all the test samples. As I said, the data was downloaded from the University of Victoria. And here's what my model looks like. So I define a modular CNN model where for an input shape and output shape, a convolutional kernel size, and a number of convolutional layers, I create a sequential model with a flatten, a dense, and then a softmax layer for prediction. I then loop over different versions of the model, train it, and then evaluate it on the test sample. And as you can see from my results, I have very, very good accuracy.